Hi, and welcome back to Particleworks Power-ups. Today's request comes from a Gearbox manufacturer. They told us we would like a method to automatically import all of the geometry for a gearbox simulation and apply all of the subsequent motion from a CSV file. Please create a macro to do this for us. Creating a scene with parameterized variables is something I find myself doing quite often. While this does front-load a bunch of work, it will inevitably help you save time later down the line if you're running multiple simulations with a few changing variables. For this script, I need a couple of external files. A CSV file stating the STL file name, RPM, center of rotation, and parent, and a directory containing all of the STL files, with their names matching the name in the component field of the CSV. For the script itself, I'm starting here with the usual initiation, i.e. setting up the bin folder, importing pwpy, and setting up the session and project. I begin by importing the necessary modules. For today, those are System, OS, and Pandas. I then create a dialog box using the Particleworks API. For this script, I have 3 variables that I want the user to be able to select using the dialog box: a file path for the CSV, a file path for one of the STL files, and the axis of rotation of the gears. This script assumes all gears are rotating about the same axis. The axis of rotation would need to be brought into the CSV file, or some other similar method, if that was not the case. D.ask is what triggers the dialog box, and will be false if the box was closed, so system exit is preventing an error in this case. The variables from the dialog box are assigned in the code, and a dictionary is used to convert the axis from XYZ to how they are assigned in Particleworks, i.e. 0, 1, 2, respectively. In version 8.1, you can only assign a file in a dialog box, not a directory, so this code assumes that all of the STL files are in a single directory, and we use the parent directory of whatever file you designate in the code. I read in the component CSV file into a pandas data frame. Next, I create a polygon material to assign to all the components I'm going to import. Specific settings could be applied here if they are required. I then loop through each component name in the CSV file and strip the names to get rid of any blank characters. This name is then used to build the file path to each STL file. A blank polygon node is then created for the model to be applied to, and the node is given the name of the component. The model is applied using the read model file function, and the previously created material is assigned to the node. The model is then imported to the project using the import project function. After all the models are imported, I then loop through all of the nodes and apply the relevant RPM and centers. I am doing this in a try except, as this CSV file uses grounded to indicate a non-moving part. This could just as easily be done using a 0 for the RPM. The except will trigger when the float function fails, as the input string contains non-numbers, in this case just moving on to the next item in the loop. To assign the rotation, an animation is needed. The X component of the animation is time, and the Y value is the variable you are changing. Unit is defined as the default is angle, and rotation is applied using the set animation function, using the property name, axis, and animation that we have created. The parents of any components are set using the transform parent property. This is assigned using the node ID for the parent node, so we find the node and then use the .id to get the ID. This is done in another loop to ensure that the parent node is already imported, otherwise you would need to be rather careful to ensure that any parent nodes come first in the CSV file. To cap off the script, we just need to write the scene to save any changes that we've made. After a final check for typos, the script is ready to go. For the script, I'm going to create a completely blank project. I first run the script and select the CSV and STL file paths. You can navigate to them using Windows Explorer by clicking the 3 dots, but I have the required file paths to hand, so I am copying and pasting them in. I then select the relevant axis, for this case the Z-axis. The code will then rapidly import all of the models and apply the relevant RPMs and parents. When it is finished, we can see that the parent and all of the RPMs have been applied correctly. If you're looking for a more efficient way to use Particleworks, or have a specific issue that you would like support with, then our contact details are on screen now. For more information about our full API online training course, please visit the contact page for details. See you next time.